Well, good evening, everybody. My name is Zack. I'm the Director of Education at Florida Oceanographic Society, and you have no idea how excited I am to be back in the Blake Library running the 2023 Coastal Lecture Series. Can you believe? The applause really belongs to all of you. We wouldn't be able to do this series without an amazing audience and without the support of MCTV and the Martin County Library System and the folks here at the Blake Library. So I'll get my thank yous out of the way right up front. But most importantly, I want to thank all of you. I just can't believe it's been 3 years since we've looked at each other face to face in this room to do a lecture. We finished up the 2020 series right at the very beginning of COVID. And in 2021 and 2022, we went entirely online. I know a lot of you joined us on Zoom, but just out of curiosity, how many of you are joining us for the very first time ever, whether Zoom or in person? Great, well, thank you for coming out. We do, believe it or not, have a Zoom audience tonight. Last time I checked, I'm up here floating around between an iPad and a computer and my audio, but I just looked before I started. We've got another 60 folks watching live online, so hi to our Zoom audience. Now, this is normally where I introduce tonight's speaker. I'm going to skip that part and jump right into our presentation. Tonight's story is all about algae. Now, I promise you, I'm not going to cover everything. This is too big of a story to tell in a short format like the Coastal Lecture Series. So if I skip over something, it's probably intentional. I just can't cram all of this into such a short presentation. The other thing I want to mention is that the stories we're telling tonight are relevant to all of you. I know some of you are visiting Florida from out of state. I know my Zoom audience, you guys are from all over the place. These stories are framed in a Florida context, but I promise you, all of the things we're going to go over tonight have a global significance. So Florida is a pretty special place, especially when it comes to water. In fact, our state is built around water. We have more miles of coastal shoreline than any other state in America, other than, very good, Alaska. We have 11,000 miles of rivers and streams, and clean water truly drives our environment and also our economy. I always like to remind people, you don't have to be a dyed-in-the-wool environmentalist to care about this stuff. I imagine if you're at an environmental lecture series, you probably lean a little bit in that direction. But in reality, we should all care about this. Because this affects our health, it also affects our economy. There are businesses that are closely tied to clean water. Think about the tourism and hospitality industry. If your industry relies on clean water, even if you're not an environmentalist, you still need to care about it. Unfortunately, like so many places, Florida's dealing with some major environmental issues. Tonight, we're not going to cover all of those environmental issues, but we are going to talk pretty heavily about one of the most important environmental issues our state's facing, algae and algae blooms. But again, I want to remind you that these truly are global issues. I can just about guarantee that no matter where you're viewing from tonight on Zoom, somewhere in your state, there's a lake or a pond that experiences algae problems during the summertime. So today's story is a Florida story, but it's really using Florida to put these algae blooms into a bigger context. A lot of our story tonight will revolve around estuaries. Estuaries are places where freshwater and saltwater mix together. So a classic example of an estuary is a place where a river flows into the sea. Think about Chesapeake Bay. It's where the Susquehanna River flows into the Atlantic Ocean. And as that fresh water mixes with the ocean water, we end up with an area of brackish water. And that brackish water becomes a very important home for so many organisms that we value. So these are important places. In our part of Florida, we have an estuary that is a river flowing out to sea. Right down here, the St. Lucie River is an example of a classical river mouth estuary. But we have another type of estuary in Florida that isn't a river flowing into the sea. For that matter, it's not a river at all, even though the word river is in its name. In our area, the Indian River Lagoon is a critical estuary. In fact, at least at one time when it was healthy, it was considered to be one of the most biodiverse estuaries in North America. So really important body of water. It starts all the way up here, just south of Daytona Beach at Ponce de Leon Inlet, and it runs down to Jupiter, about 156 miles. But runs is not real accurate. It actually doesn't go anywhere. It's just a lagoon that is nestled between the barrier islands that run up and down Florida's east coast and the mainland. It gets fresh water from a series of rivers and creeks on the western shoreline, and it gets salt water from a series of inlets that perforate the barrier islands. So it's still a brackish water environment, but it doesn't really go anywhere. Today's talk is going to focus heavily on the Indian River Lagoon as well as the St. Lucie estuary. As we begin to think about algae, it's important to recognize the fact that there are literally thousands and thousands of different species of algae on our planet. Most of them aren't bad. They're good. A lot of algae species provide food and shelter for wildlife. For example, this stuff. This is sargassum. You've probably heard it called seaweed. Seaweed's just another nickname for certain types of algae. This is the prickly, squishy brown stuff that washes up on our beaches certain times of year. Sargassum, when it's floating out in the ocean, is usually considered a good thing. You can see in this image literally hundreds of fish hanging out under these mats of sargassum. We see little fish, like you see in this image, but bigger fish are nearby. Predatory fish like to hang out around sargassum because there's lots of food. If we were to zoom in on this sargassum, there are tiny shrimp and crabs hanging out in there. If we were to look at it from above, where do you think baby sea turtles spend the first couple years of their life? Hanging out in this stuff. So this is a great example of a type of algae that's good. Another good type that you guys are probably familiar with is kelp. The same story. It provides a great food source and a great shelter for wildlife. So it's important to see that the news stories we hear all the time about bad algae only represent a subset of the algal species that are out there. Obviously, those are the more important stories, but it is still good to know that they aren't always bad. So what are they? First and foremost, algae are not plants, but they're pretty close. I think of algae as plant-like things that aren't quite plant-like. Plants have roots, plants have stems, plants have leaves. Algae don't have roots. They don't have stems. They don't have leaves. Don't trust your eyes. There are no leaves or stems in that picture. But they have structures that work like roots, that work like leaves, that work like stems. So they do a lot of the same things that plants do. And in the world of algae, there are two broad categories. There are big types that you could see without a microscope, and there are little types that you need a microscope to see. The big types of algae are called macroalgae. These are the ones that we also call seaweed. So kelp and sargassum that we just looked at are macroalgae. These are the ones that look, to the naked eye, like little underwater planty things. There are also lots and lots of algae that are microscopic, and we call these microalgae. They are so tiny that if I had a glass filled with microalgae up here, it would just look like water until I put a drop under a microscope. Most harmful algae blooms are caused by the latter, the little tiny microscopic organisms that you need a microscope to see. I will give you some examples later of harmful algae blooms that are caused by the bigger ones, but they're few and far between. In Florida, the vast majority of our bad algae stories relate back to microscopic organisms. This is a great example. This is a satellite image of the northern Indian River Lagoon. Just to give you some context, this is the Kennedy Space Center where last night's SpaceX launch went off. Did anybody hear it? It's pretty cool, right? This is the Mosquito Lagoon, the Banana River, and the northern Indian River. Combined, this is all part of the Indian River Lagoon system. And you could see from outer space that that water is pea soup green. But if I scooped it up into a clear glass, it would look pretty clear. You wouldn't see anything in it until you looked under a microscope. Over here is the St. Johns River. That's clean water. And you could see it's black, it's not green. So we'll talk more about microalgae as we go through tonight's program, and we'll cover a few specific examples. But one of the things I want to dispel right off the bat is the fact that not all harmful algae blooms are caused by Lake Okeechobee discharges. I know Lake Okeechobee discharges are important to us here in Stuart, Florida, because they impact us disproportionately. And there are certain algae blooms that are fueled by Lake Okeechobee discharges. And taking it a step further, there are certain algae blooms that only occur when they're discharging water out of Lake Okeechobee. But blooms like this have nothing to do with Lake Okeechobee discharges, and I'm going to try my best to separate those two as we talk tonight. This is an up-close view of what you just saw in that satellite image. This is a type of algae bloom that's only recently, within the last decade or so, started to impact the Indian River Lagoon. Sometimes you'll hear this referred to, at least when it first appeared in 2011, as the super bloom. This particular group of algal organisms, and it's more than one species, they make the water look like pea soup. This is another bloom. This one has a different nickname. It's called the brown tide. It's another bloom that never historically existed in our area, and then all of a sudden, like a light switch, in about 2013, 12 or 13, it suddenly appeared. And this particular brown tide organism has more of a chocolate milk color to it. And if you're out in the water, these are subjective terms. You could just tell sometimes there's a little bit more of a brown hue or a little bit more of a green hue. Either way, the water looks pretty revolting. If you were to take a drop of that and put it under a microscope, this is what you'd see, little tiny dots. And those dots have a name. The organism that causes the brown tide is Ario umbra. You guys are all familiar with invasive species, right? I gave a lecture a few years ago about invasions. There's a possibility that this little tiny organism is invasive to Florida. We don't know for sure, but what we do know is that it was found in Texas for a long time, but not found in Florida. And then all of a sudden it appeared in Florida. And it's not implausible to think that it might have gotten transported here by accident. If I were to ask you what the worst invasive species in Florida are, I'm sure you would say pythons, lionfish, iguanas, tegus. As a biologist, I'm much more concerned about little things like insects and fungi and bacteria and algal blooms. This particular bloom, as I mentioned, makes the water look kind of brownish green, but then there's this other much darker brown area outside of the bloom. That is seagrass. Seagrass is such an important part of a healthy estuary. It provides shelter and food for so many organisms that we value. During a bad algae bloom like this, if you were to wade out into the water and reach in with your hand would disappear almost immediately. Sunlight cannot get through this soupy concoction of algae, and as a result, the seagrass beds that grow on the bottom, they run out of light and they start to die. Whoop, wrong button. In the last decade or so, we've lost more than 50,000 acres of seagrass in the Indian River Lagoon. That's 50,000 football fields. That's probably somewhere in the 90 to 95% range of what we used to have, depending on how you analyze the data that are coming in right now. Here's a really graphic example. I don't need to give you percentages here because it goes from practically 100 to practically 0. This is a spot in the Indian River Lagoon I used to love to fish. This is a quarter-mile wide bed of seagrass that ran for miles north and south. 2009 is not that long ago. In 2011, we had the super bloom. In 2012, we had our first brown tide, and by 2013, in this area, the grass was completely gone. This is a barren, sandy moonscape in 2013. That's a decade ago. How's it look right now? Well, I'd like to say I went on a fact-finding trip last week because of this lecture. I actually didn't know I was even giving this lecture last week, so I just went fishing. But I was up in this area, and what I saw was that there wasn't a single blade of seagrass. I didn't see a blade all day. But if you were to look at this from satellite, here's what it looks like right now. Looks great, right? That's a big, wide green band right in the area that it used to exist. But when you get in a boat and you start looking at it, it doesn't look quite right. That's not seagrass. That is another kind of algae bloom. This is a type of macroalgae called caulerpa that can bloom sometimes when the health of an estuary is a little bit out of whack. We've got issues with water quality. This stuff can grow. It's not as harmful as some other types of algae, but it absolutely doesn't belong there, and it's not providing the benefits that seagrass would. This is a sign that something's wrong, and even though it's better than having just a sandy moonscape, it isn't providing the habitat or the food that our beloved animals need. Things like game fish, things like sea turtles, things like manatees. And this is one of the reasons why Florida is having a manatee crisis. I just looked at the latest numbers from 2022. We're only a week into the year now. Last year, we had 800 manatee deaths in Florida. That's not a record. The year before, in 2021, we had 1,100. That was a record. In many cases, those manatees died of starvation because their seagrass beds had literally disappeared. They had nothing left to eat, and it's not getting any better. Now, there is a little bit of a twist. Manatees would rather be warm than have a full belly. And in certain parts of Florida, we operate power plants that produce warm water pollution, thermal pollution. The manatees have learned to hang out around these power plants in the winter, and they've stopped utilizing their historic migratory paths. Manatees use social learning. They teach their offspring life lessons. So mother manatees aren't teaching their children to migrate anymore. And as a result, manatees are gathering in areas where there's warm water, but there's no food for them to eat. And that's a big part of why they're starving. That's also why the U.S. Fish and Wildlife Service is doing this ludicrous thing of feeding manatees lettuce. I don't know where you guys stand on that, but I could tell you that's not the solution. We need to fix the water. We need to get the grass to come back, and then the manatee population will stabilize at a natural level. So I mentioned we've got some algae blooms growing in the Indian River. I talked about brown tide. I talked about a super bloom. They are not toxic. I haven't said a thing about toxic algae yet. I'll say a lot about it later, but these aren't toxic blooms. However, they can still cause big problems like fish kills. This is a fish kill that occurred in the Indian River Lagoon in 2016, and it was caused by algae blooms like we just looked at. So how does a non-toxic algae bloom cause that much harm? And I want to remind you, this is one person's backyard. This bloom extended 30 miles, and it only lasted 2 days. But 30 miles times 2 days, I counted these fish one day. This photo has over 5,000 fish in it. We're probably talking about over 1 million fish in a 2-day event that died from a non-toxic algae bloom. It has to do with oxygen. Remember I said earlier that algae are kind of sort of plant-ish? Well, like plants, under ideal conditions, algae take in carbon dioxide, and with a little bit of sunlight magic, they create food and give off oxygen. A lot of the oxygen that we're breathing right now was created earlier in Earth's history by algae and algae-like organisms. However, sometimes algae do the opposite. They take in oxygen. And that's what happened with that fish kill. In that very specific moment, the algae bloom kind of flipped a switch, and it started using oxygen, and as a result, we lost a tremendous amount of fish in a very short period of time. So what's causing all this stuff to grow? It depends on where you're at, but in some areas, we've got a pretty obvious answer. This is somebody spreading fertilizer during the fish kill that I just showed you. This is literally a waterfront home on the Banana River, and somebody is pushing a fertilizer spreader around with millions of dead fish floating in the water. So we really need to think about nutrients. But nutrients, kind of a tricky thing to talk about because normally they're good, right? And you could probably read the future and know that I'm about to say they're bad. Well, it has to do with what they are and how much of them we're exposed to. By definition, a nutrient is a substance that provides nourishment essential for growth and the maintenance of life. For humans, our nutrients are protein, carbohydrate, fats, and then we take lots of micronutrients in our vitamins, zinc, iron, selenium, etc., etc., etc. If we take too much of a good thing, it becomes a bad thing. Zinc is a good example. When we have a cold, we pop our little zinc supplements in and we think we're fighting off our cold. But if I were to give you a whole bunch of zinc, you'd probably die from it. The same thing applies to the nutrients that are fueling algae blooms, namely nitrogen and phosphorus. So nitrogen and phosphorus are the key nutrients that are triggering a lot of the algae blooms that we're going to talk about tonight. And I have nitrogen and phosphorus underlined there. If you've done any gardening and you buy a bag of fertilizer, you are going to see NPK on the back of your fertilizer bag. N for nitrogen, P for phosphorus, K for potassium. Those are the nutrients that we throw onto plants to make them grow quicker. So of course it makes sense that since algae are kind of sort of plant-like, when we put nutrients like nitrogen and phosphorus in the water, they will fuel the growth of algae. I'll repeat this a few times tonight probably, but I look at these nutrients as gasoline on a fire when we're dealing with an algae bloom. I'm going to take a step back and say that I am grossly oversimplifying this next sentence. But Florida's algae issues boil down to two things: fertilizer and waste. Now, it's obviously much more complex than that, but in simple terms, our nitrogen and phosphorus sources are fertilizer and waste. Fertilizer can mean a lot of things. I bet most of you immediately think of this: large-scale farm fertilizer. But it's not just about agriculture. Guys, remember, every one of us eats food grown on a farm every day. Agriculture is not always the boogeyman with these conversations. Obviously, we want to make sure that we're doing agriculture right, and unfortunately in Florida, we're not. But we have to realize that there are ways that we can coexist in a society where we grow food that we eat, and we also can do that without destroying the environment. So in addition to farm fertilizer, which in Florida is the biggest source of fertilizer-based nutrients, we also have to think about the fertilizer that goes on golf courses and parks and baseball fields and even our own backyards. For those of you that live in Florida, if you fertilize your grass, you are guilty of causing part of this problem. Now, you're only causing a really tiny part of it, but you're still part of it. And here's why. Even if you're not a waterfront homeowner, in many areas of Florida, you've got groundwater right below your yard. So when you fertilize, that groundwater will eventually absorb the nutrients from your grass. And then we know that groundwater moves around and ends up in our estuaries, and it can fuel algae blooms. So fertilizer is part of the story. Agriculture is a big part of that story, but it's not the only problem with fertilizer. Separate from fertilizer is waste. Waste comes in a couple of different forms. It can come from agriculture, so intensive animal agriculture, hogs, beef cows, dairy cows, poultry. Those farming practices do produce nitrogen and phosphorus, but in reality, the biggest source of waste that you and I need to think about is you and I. A lot of people are moving to Florida every day. That's a lot of toilets that are getting flushed. And sadly, our state has a failing wastewater infrastructure. You don't have to look real hard on the news to find stories about sewer pipes that have crumbled and cracked and are now leaking, or wastewater treatment plants that can't handle the capacity of a storm event. We had 2 hurricanes that came through Florida this year. We had some pretty big failures of sewage plants that spilled raw sewage into the Indian River Lagoon and other estuaries. So we need to do a better job of improving the way that we deal with our own waste if we want to have clean water in Florida. The other thing we need to think about is septic. Some of you may not own a home with a septic tank, so I want to just take a second to explain what septic tanks are. They are a means of treating waste in your own backyard. If you're not able to connect to a wastewater line, a main sewer line that goes to a wastewater treatment plant, your other option is a septic tank. And unfortunately, that's the only option for a lot of us. And the way a septic tank works is basically you have a big tank buried in your yard. When you flush, the liquid portion stays up here, the solid portion sinks down here, and eventually that liquid portion then goes out of the tank and into a perforated network of pipes called a drain field. And those pipes trickle your raw sewage into the ground. If you have a thick enough layer of soil below your septic leach field, the bacteria in the soil will break down that waste and the water is rendered mostly harmless. But if you've ever dug a hole in Florida, you know, A, that we don't have soil, we have sand and limestone, and B, if you dig too deep, you run into groundwater. In most counties in Florida, you only need 2 feet between the bottom of your leach field and the top of the water table. 2 feet's just not enough to clean that water. So even if you put in a brand new state-of-the-art septic tank, if you only have 2 feet between the bottom of that leach field and the top of the water table, you are still putting nutrients into the groundwater. Now, there are advanced wastewater treatment options that you can bury behind your house, but they're expensive and they require maintenance. So most homeowners are not going to make that transition unless they're being forced to. And this is where politics comes in. We'll talk a lot about politics tonight, but until you and I are held culpable for hurting the environment, most of us aren't going to make major lifestyle changes. We might recycle or use a reusable tote bag or a reusable water bottle, but to pony up a big, expensive infrastructure change like upgrading your septic tank, you're not going to do that until you have to in most cases. And that's where we need leadership that will make those changes more painless for us and provide support for homeowners who need to transition to a better wastewater option, or ideally get us hooked up to a main wastewater treatment facility. I mentioned that nutrients fuel algae blooms, but never in a million years did I think I'd be giving a talk with photos of fish that are growing algae. This is a sign that we really have too many nutrients in our waterways. The fish on the left was caught by a concerned citizen. They gave it to me. I took some pictures of it. I was flabbergasted, but I thought it was a one-time event. And then about a year later, I caught the snook on the right, and it had the exact same type of algae growing from its gills. When I see things like this, it's a very clear warning sign that our waters are incredibly broken and nutrients are the big problem. Now let's switch gears a little bit and move on to the second main type of algae we're going to discuss tonight. The ones we've talked about already, not toxic. This stuff, toxic. This is the red tide. The red tide is another bloom of algae that occurs in Florida, but it's different in that it produces a neurotoxin called brevetoxin. And that brevetoxin impacts lots of animals. Red tides are known for the fish kills that they produce, but they also impact air-breathing animals, things like sea turtles, manatees, dolphins, whales, us. Have any of you ever been around a red tide bloom before? Some of you have. For me, when I'm exposed to it, I start coughing uncontrollably, and I literally can't stop until I leave the area. One time, I surfaced from a scuba dive in the middle of a red tide, and I coughed for 20 minutes on my swim back to the beach. Imagine being a marine animal that doesn't get a break in 20 minutes. It lives in that water, and it's breathing it constantly. It's exposed to it constantly. If you put a drop of that brownish water under a microscope, in this case an electron microscope, this is what the red tide organism looks like. It has a name. It's called Carina brevis, and it's a type of dinoflagellate. Dinoflagellates have little squiggly bits that stick out of them, and they work like tails, so they can swirl and twirl in the water. They're not great swimmers, but they're able to move around a little bit. And this little organism packs quite a punch. It causes major problems, and it affects not just the environment, it affects the economy in areas where these blooms occur. In Florida, most of the time, our red tides are restricted to the Gulf Coast. I just pulled this image off the state's website. This is the most recent map showing a pretty serious red tide bloom occurring roughly between Tampa Bay and a little bit north of Charlotte Harbor. That particular red tide was probably triggered by Hurricane Ian and Hurricane Nicole. During those storms, we got a tremendous amount of rainfall, and that rainfall carried nutrients, nitrogen and phosphorus, from terrestrial areas into our estuaries and out into the Gulf. Those nutrients then fueled the red tide, like putting gasoline on a fire. You'll sometimes hear people in certain positions defend the red tide in a way and say, oh, don't worry, it's totally naturally occurring. Humans aren't part of the problem. That's not accurate. Part of it's accurate. The red tide is a naturally occurring organism. It's not laboratory created. It's found in the environment. There are even reports of the red tide dating back to the early Spanish colonial days. Sailors wrote reports that basically describe a red tide event. But today's red tides are very different than historical red tides. Today's red tides are closer to shore, they're more intense, they're more widespread, and they're longer lasting. We had a red tide 2 years ago that lasted over a year without a break. That's because of the nutrients that we are putting into the water. Right now, the East Coast is okay, but when you look back to 2018, oh, I forgot, I have a picture. I pulled this off, just saw this on social media. Sarasota Magazine put a really great aerial photo up. This gives you an idea of what this frothing, foamy mass of algae bloom looks like in contrast to that beautiful clear water of the Gulf. This is toxic, and if you were to go diving under that plume, the bottom of the seafloor would be littered with dead fish, and after a few days, the beaches would be covered in dead fish. And again, going back to the economy, if you're a restaurateur or a hotel owner, you're not going to have any bookings when the red tide is intense. Tourists are getting pretty savvy, and they know to call ahead, and they'll cancel their reservations if an area is being impacted by this algae bloom. It's just another example of all of us needing to care, even if you're not a dyed-in-the-wool environmentalist. This affects all aspects of our economy. In 2018, I was starting to mention that the bloom on the West Coast got so severe that it wrapped all the way around Florida and impacted us on the East Coast. Right here in Stewart, we had severe red tide for a few weeks that year. This stuff moves in the water. Our currents carry it, and our nutrient-rich water is coming out of the St. Lucie estuary. Probably gave it a little bit of a jump start when it got into our area. Now, the final type of harmful algae bloom that I'm going to talk to you about tonight is the most important one. This is the scary stuff. This is the stuff that I really want all of you to learn about. This is a type of toxic cyanobacteria. If you were to put a drop of this under a microscope, little brown dots, not very impressive, but it's bad stuff. The species of blue-green algae that impacts us in Stewart, and honestly globally now, is called microcystis. And like we said earlier, it's just one species out of many. Like algae, there are thousands of different kinds of cyanobacteria on our planet, and only some of them are harmful. So what are they? First and foremost, they're not algae. Even though you'll hear them referred to sometimes as blue-green algae, that's not really an accurate description. They're tiny bacteria, but they're like algae in that most of them use sunlight to grow. They grow in a lot of very harsh environments. If you've ever seen like a National Geographic special where they're deep underwater with a submersible at the hydrothermal vents where hot water's boiling out of the seafloor, the animals that live around those vents rely on cyanobacteria for food because the cyanobacteria can thrive in harsh environments. If any of you have visited Yellowstone, the yellow ring around prismatic hot springs is a form of cyanobacteria that can tolerate nearly boiling water. And just a cool side story, because I think it's neat. As you get further away from the blue, the color shifts. And each of those colored bands, as you get further and further out, is a whole different community of bacteria and cyanobacteria. And each community tolerates progressively cooler and cooler temperatures. So near boiling at the water's edge, maybe 140 degrees a little further out, maybe 130, 120. They all tolerate hot water, but their colors change as they get further and further away because the species composition differs. Cyanobacteria also end up in our food sometimes. Your green drink, your smoothie that you buy might have spirulina in it. Spirulina is cyanobacteria. Presumably, it's healthy for us to eat. Personally, I wouldn't eat it. I know enough to know that we don't have a really great understanding of how these things work, when they're toxic, when they're not toxic, and how they build up in our tissue. So if you do drink drinks with spirulina or chlorella, do a little homework and make sure you're doing the right thing. Again, the specific type of blue-green algae that impacts our community out of the thousands of species on Earth is called microcystis. Microcystis is pretty gross. When I'm around it, I get respiratory issues. My eyes water. It stinks. It's gloopy and clumpy and lumpy. And the biggest thing you'll notice is that shocking neon green color. The first time you see it, it almost looks like somebody poured paint into the water or maybe antifreeze. It's bad. It's bad because it's toxic, and it creates a whole suite of toxins, not just one, but potentially dozens. It is toxic to wildlife, it's toxic to pets, and it's toxic to people. Short-term exposure has been linked to things like liver damage, pretty bad liver damage, pretty irreversible liver damage, but the bigger concern is long-term exposure. There is a growing body of scientific evidence suggesting that long-term exposure to cyanobacteria like microcystis might be linked to certain neurodegenerative disorders like Alzheimer's, Parkinson's, and ALS. And here's another scary thing. We can't predict when this stuff is going to be toxic. It can turn toxicity on and off like a light switch. For example, this might be your backyard. You call the Department of Environmental Protection, they will come out and scoop some of that up, they'll sample it, and they might get back to you and say, hey, it's the bad stuff, but it's not toxic. Great news, right? By the next day, it might be deadly toxic. And unless you're sampling it day after day, there's no way to predict when it's going to go from a nuisance to a downright toxin. This is a publication that came out this year that adds increased evidence to this theory that a certain toxin in microcystis, something called BMAA, beta-methylaminoalanine, might be responsible for brain diseases like ALS. The theory is that this particular amino acid may get into the proteins of our brain and cause them to misfold, and it might cause plaques to develop. I have to be careful when I talk about this, though, because we do not have definitive proof. The reason we don't have definitive proof is it takes decades to develop. We have really good correlations in multiple systems, but we don't have definitive proof yet. In my opinion, the correlations are strong enough that I take this very seriously. This is what it looks like. How many of you have seen this in person? Have any of you been here? So for folks on Zoom, about a third of our audience has seen this. For the rest of you, this is not altered. There's no filters applied to this. I haven't enhanced the saturation. I don't even know how to do that. This is right off of my phone in downtown Stewart. It looks like a green oil slick, and it just goes on and on and on for hours in this particular area. If I kept filming, it would never have ended. It is not unique to Florida. I said earlier that my story tonight is just using Florida as a great reference point for a discussion about a global algal problem. This stuff's found all over the globe. Here's a news story from Africa. 300 elephants were found dead in Botswana around watering holes where blue-green algae was growing. That gives you a pretty good idea of just how toxic these compounds can be. Here in the United States, there have been dozens of sad stories about people's beloved pet dogs dying after swimming in ponds and lakes where blue-green algae was present. Right here in Stewart, multiple people that we know have lost pets to this. It doesn't take much. A quick swim, a few laps of water, maybe a few licks of a paw. That's enough to get toxic levels of cyanobacteria into the animal's body, and it causes liver damage that's not typically reversible. We also have to think about our own drinking water. Our drinking water isn't safe from this stuff, particularly in communities where drinking water is pulled from lakes where toxic cyanobacteria grow. Toledo, Ohio is everybody's favorite example of this story. Sorry if anybody's from Toledo. Toledo gets their drinking water from Lake Erie. In the summertime, Lake Erie can experience awful blooms of microcystis, the same species that we deal with right here in Stewart. In 2014, the water supply in Toledo was compromised, and the city had to tell 400,000 people not to drink their tap water. Think about that for a second. This is a first world city with first world water treatment plants, and they couldn't figure out how to filter this stuff out. And we still don't really know how to filter it out of water. 500,000 people without drinkable tap water because of a prehistoric, microscopic, toxic bacteria that's being fueled by nitrogen and phosphorus that you and I are putting in the water. And that's not a story unique to Toledo. Right here in Palm Beach County, the summer before last, they had to issue multiple drinking water advisories for the exact same reason: toxic levels of cyanobacteria in people's tap water. So now we need to step back and look at this from a little bit of a bigger perspective, in this case from outer space. Whether we're talking about algae blooms in the Great Lakes, look at Lake Erie here with a terrible algae bloom occurring, or whether we're talking about right here in Florida, or the open ocean for that matter, Earth's changing climate is impacting algae blooms. Remember, you won't hear a good scientist that works in the climate field say the phrase global warming. The media uses that. Scientists don't. Not all of Earth is warming. There are places that are warming, there are places that are cooling. There are places that are warmer, there are places that are drier. Some areas are experiencing very small changes, other areas are experiencing bigger changes. But the fact of the matter is, our climate's changing. As a scientist, and my peers and I are emphatically confident that human actions are driving this. But even if you don't buy that story, that's okay. You have to agree that our climate is changing. We've got rock solid evidence to show that it's warming. And in some places, precipitation's increasing. Those two factors, whether they're driven by humans or not, they're causing algae blooms to become more of an issue. Warmer water causes algae to grow faster. Longer warm seasons give these blooms a longer time to proliferate. If you live up north, you might have noticed that your first snowfall is happening later in a lot of areas. Your last snowfall is happening earlier in a lot of places. That's a bigger chunk of the year for blooms to grow. Add to that, areas where climate change is causing precipitation to increase, you get more runoff, and that runoff carries more nitrogen and phosphorus into the water, fueling these blooms. That's a pretty big scale, but let's talk even bigger. Earlier, I mentioned that sargassum is usually a good type of algae. Well, in recent years, sometimes it misbehaves. There, in the last decade or so, have become portions of the Atlantic Ocean that are inundated with huge blooms of sargassum. Historically, most sargassum in the North Atlantic grew out here, between the United States and Africa, in an area called the Sargasso Sea. But in 2011, scientists started to notice a new trend. There was a brand new area of sargassum growth extending from Africa through the Caribbean into the Gulf of Mexico. By 2018, that bloom had reached 5,500 miles from end to end and was considered to be the largest algae bloom on Earth. But it's sargassum. I said it was good, right? It's good when it's in the right place at the right time, but when your beaches become buried in it, it affects tourism. and it affects wildlife. Sea turtles can't nest on those beaches, and birds can't nest. And as this stuff rots and decays, it kills coral reefs. So there are places throughout the Caribbean, both island nations and then mainland Mexico and Honduras and Belize, that have lost their tourism industry, or at least partially had huge tourism setbacks because of this algae bloom that's occurring out in the open ocean. We don't know exactly what's causing it, but there is pretty good evidence to suggest that Earth's warming climate is allowing this bloom to grow a little quicker, combined with what we've done to the Amazon basin. We've turned huge portions of the Amazon into farmland and ranch land, and that polluted Amazon water is running right out into the area where this bloom is intensifying. So there's a pretty solid body of scientific evidence to suggest, not prove, that this new expanse of sargassum is a human-driven algae bloom at an extreme. Now let's circle back to Florida. Watery state. Water drives our economy, water drives our ecology. And I spent a lot of time talking about one specific type of algae that's a particularly big threat, that microcystis stuff. Well, there's something I haven't mentioned yet. Microcystis is a freshwater species. It's not a saltwater species. So in theory, at least, here in coastal Florida, it shouldn't be a big deal, right? Well, unfortunately, it is, because the blooms that I showed you in those photos in that video, they are intentionally being dumped on us from somewhere else. They're coming from Lake Okeechobee. Now, Lake Okeechobee is an amazing body of water. Some of you may have heard me talk about the lake in the past. It's just a really cool place. It is one of the largest natural freshwater lakes in the United States, and it used to be the watery heart of the Florida Everglades. If we could somehow step back in time, we'd see a very different Florida. Oh, let's step back in time. This is my favorite old map of Florida. This is an 1856 map of our state, and the reason it's my favorite is it's the oldest map I could find that didn't look like it was drawn by a second grader. It's an accurate map, and from this map, you can see what Florida was meant to look like. You could see how big the Everglades used to be. So I want to quickly give us a float down the Everglades from its headwaters, all the way up here near Orlando. You might not realize that the Everglades begins in the Orlando metro area in a little creek called Shingle Creek. Shingle Creek used to flow into the Kissimmee Chain of Lakes, and the Kissimmee Chain of Lakes would flow into the Kissimmee River. The Kissimmee River was a twisting and turning oxbow river, and during the wet season, that entire river would spread out into a big floodplain marsh. Those wetlands filtered the water as it flowed into Lake Okeechobee. During the wet season, the lake itself would slowly fill up and expand. I've read old accounts of the lake nearly doubling in size during the wet season. The whole perimeter of the lake would become a giant, shallow wetland. During the dry season, there were times that it shrunk to a much smaller size. The bottom was hard sand, the water was clear, the fish were abundant, the waterfowl were abundant, and the lake itself at that time, as I mentioned, was the heart of the glades. Water used to flow over the edge of the southern shoreline of the lake, and it would spread out to form the Everglades, or as Marjorie Stoneman Douglas called it, the River of Grass. That was a great nickname for the Everglades because at one time, it was a big grass-filled river. And when I say big, I really mean big. The western edge of the River of Grass was about here. The eastern edge was about here. 40 miles wide at its widest, 100 miles long. The water would flow gently and slowly from the bottom of the lake all the way down to Florida Bay and the Florida Keys. If you put dye right here, the water would very slowly travel south. And the one thing I want you to notice, there was no natural connection between the St. Lucie River and Lake Okeechobee. None. In fact, what we know of today as the St. Lucie River was roughly restricted to the area east of I-95. Everything west of town was wetlands that didn't go anywhere. When it rained, those wetlands would percolate into the aquifer and recharge the drinking water that so many of us rely on today. There was also no connection between the Caloosahatchee River and the lake. The Caloosahatchee was a much bigger river, but it never reached all the way to the lake. Because it was a bigger river, it needs more fresh water than the St. Lucie does, and we'll talk about that later. But just understand, there was no natural connection between these systems. Unfortunately, we've kind of messed things up. Back in the late 1800s, our government didn't see any value to the Everglades. That was a period in time where growth was more important than the environment. And there was a major effort to drain the glades. They wanted to dry out as much of that land as possible, primarily to create farmlands and cities and towns. They started this draining process by dredging enormous man-made canals to drain water off the lake and out of the glades. And then, following two big hurricanes that hit our area in the 1920s, they began construction on an earthen flood control dam that would eventually go all the way around the entire lake. That dam became the Herbert Hoover Dike. The Herbert Hoover Dike cut off water flow to the Everglades, allowing us to permanently drain about half of the original Everglades ecosystem. Today, if we look at communities in western Palm Beach, Dade, and Broward counties, those towns were built on the skeleton of the Everglades. I grew up in the western part of Broward County, and as a little kid, I never understood why there were so many old cypress trees in my neighborhood. And then I found some 1940s aerial photography after these canals had started to be built, but before any houses were built, and you could literally see that my neighborhood was built on top of the drained Everglades. But even bigger than urban development in South Florida, draining the glades allowed us to create the 700,000 acre Everglades agricultural area immediately south of Lake Okeechobee. That farmland was built directly on top of the rich soils that used to underlie the River of Grass. Today, the most valuable crop in that area is sugarcane, and we'll talk more about that in a second. Now, when you build a big dam around a big lake, what do you do with all that water when it rains? This year we had 2 hurricanes come through Florida. There's a lot of water in the lake. What do? Well, water managers decided to use those man-made canals to move water out of the lake. Specifically, one big canal that goes west to the Caloosahatchee and one big canal that comes east to the St. Lucie, right here in Stewart. In a bad year, those canals can dump hundreds of billions of gallons of lake water out to sea. Here's an aerial view of the canal that we deal with here in Stewart. It connects from the lake through agricultural lands in western Martin County and dumps into the South Fork of the St. Lucie, through the Indian River and out to sea. I also want to point out these other 2 canals, the C-23 and C-24. They do not connect to Lake Okeechobee. Sometimes you'll hear people say that they do, but that's not accurate. These are drainage canals that were meant to drain all of those wetlands that I mentioned existed in western Martin County historically. When it rains in western Martin County, to keep the land from flooding, these canals discharge water into the St. Lucie. That is separate from the water coming out of the lake, but it can be just as harmful. This fall, we did not get any Lake Okeechobee discharges, but our water still looked awful. That's because of water primarily coming out of the C-23 and C-24 after the hurricanes came through our community. There's a connection between the lake and our community, and it brings with it horrible toxins. The lake itself is so polluted that it really acts as like a supercharged cauldron of algae growth. In a bad year, you can see these blooms from outer space. In a bad year, they can cover up to 90% of the lake's surface. Right here is the outlet to that canal I just mentioned, so it's not hard to follow the dots. This is an aerial view looking east. Here is toxic cyanobacteria flowing into the C-44 canal. Here's the other end of the C-44 canal, west of town, at the S-80 flood control structure. The toxic cyanobacteria is flowing directly into the St. Lucie River through our community, into the Indian River Lagoon, one of the most biodiverse estuaries in America, and out to sea. That is why we deal with toxic cyanobacteria in Stewart. But folks, I want you to know, today's story isn't just about cyanobacteria. Salinity matters too. This is a view of the St. Lucie Inlet on a good day. We are sitting right about here at the Blake Library. Florida Oceanographic Society's Coastal Center is right here. All of these dark lines that you see south of the inlet, that's coral reef. We have a beautiful area when we're managing water properly. During a discharge event, this is what our estuary looks like. Even if that water doesn't have cyanobacteria in it, it still creates a big problem. You can see it's filled with sediment, but it's also very fresh. And just those salinity changes can have an impact on plants and animals that need salt water to live. When you dump that much fresh water, billions of gallons a day, into a place that's meant to be salt water, the salinity fluctuations start to have an impact. And folks, this plume has been tracked 10 or 15 miles offshore sometimes. If there's toxic algae in it, that toxic algae goes miles offshore and can affect animals that live out in the open blue ocean. Salinity in our area has a big impact on seagrass. I started the program showing you maps of dead seagrass in the northern Indian River, and I said they're mostly caused by algae blooms. In our community, most of our seagrass die-offs are caused by LACO discharges. The water is dark and filled with sediment, so it blocks sunlight, but it's also too fresh for the grasses. Seagrass needs salt water to live, and when you inundate a seagrass bed with pure fresh water for long enough, it kills the grasses. In 2016, we had a major discharge from Lake Okeechobee. Prior to that discharge event, this area inside of the St. Lucie Inlet was a lush seagrass meadow. I still remember the first time I fished out there, it was just hard to believe how much grass was growing. In 1 year, all of that grass died. For the most part, it hasn't come back yet. This past year was the first time in 6 years that we have not experienced bad discharges from Lake Okeechobee. Even with improved water quality, we just started to see a little bit of seagrass trying to come back. But for the most part, it still looks like a moonscape out there, and I'm concerned that the water that we saw this fall from the C23 and C24 canals will set back that little bit of recovery that we started to observe. Low salinity also affects oysters. Oysters in our part of Florida are like Goldilocks. They don't like fresh water, they don't like pure salt water, they want kind of an intermediate salinity. So if salinities get too low, it can start to impact oysters. It can stress them, and eventually, if it gets low enough, it can kill them. This is a good example of some water monitoring that Florida Oceanographic Society has looked at, and what we found was that in 2018, we had a real bad year with a long discharge period. There were 127 days in the St. Lucie estuary where salinities were below the ideal level for oyster health and survival. Low salinity can also affect some of our favorite game fish species. The Indian River Lagoon used to be an angler's paradise. I've read books from the late 1800s where anglers traveled to Florida specifically to fish for our famous game fish, our tarpon and snook, redfish, sea trout. Sadly, our fishery is in a pretty major state of decline. For species like sea trout, we've learned that the survival of their eggs and larvae can be affected by salinity. So even if we have clean water, if it's a little too fresh at the wrong time of year, you might not get any surviving juvenile sea trout to replenish the population. Sea trout have become a canary in the coal mine. They used to be an abundant fish in the Indian River, but without healthy seagrass and without healthy water, I very rarely catch them anymore. So how do we fix all of this? This is how we're going to wrap up tonight's talk. It's tough. And one of the things that I haven't talked about yet involves something other than water quality. Quality is important, but we also have to think about timing and quantity. And we've really messed those things up. Remember, we are now using these canals to dump water out to sea primarily so that the Everglades agricultural area doesn't get too wet during the wet season. On the flip side of that, we are also actively working to prevent any sort of drought in the Everglades agricultural area. So during the dry season, water managers are sending water south into the Everglades agricultural area when the rest of us are suffering from really dry conditions. All the while, the Everglades down here is cut off from this water. You might be surprised to hear that even though we have a ton of extra fresh water here in coastal Florida coming through those big canals, there have been repeated drought years in the Everglades that have devastated the ecology in Everglades National Park. They're not getting enough water, we're getting too much, but the problem is we can't just send that water south as it is. Right now, the lake itself is so polluted that if we sent water south into the Everglades, we would destroy the delicate Everglades ecosystem. I might surprise you with this next sentence. The sugarcane industry isn't the worst polluter of Lake Okeechobee anymore. They used to be. In fact, for decades, they dumped polluted agricultural runoff back into the lake. And the lake became so polluted that it really led to the growth of these algae blooms on an unprecedented level. Those nutrients that came from the Everglades agricultural area historically and entered the lake have now settled down into the sediment on the bottom of the lake, which is no longer sand, it's a thick black muck. We call those legacy nutrients. During windy periods, those legacy nutrients get stirred up and they fuel algae growth. So fertilizer that a farmer put on a sugarcane field or a corn field or a pepper field in the 1940s can still be present in the lake, causing environmental problems today. Most of the pollution coming into the lake today is coming from up here. There's intensive agriculture, but there's also intensive urban growth. There are golf courses and planned communities going in left and right, and all of those nutrient inputs are making their way into Lake Okeechobee through a Kissimmee River that's not working as a filter anymore. I did say that the agriculture industry south of the lake is not the worst polluter anymore. What they are is the biggest roadblock to fixing this problem. And that brings us back to politics. We really understand the science behind Florida's water problems. We just need leadership at all levels, from county commission to Tallahassee to Washington, D.C., to help fix these problems. These are utterly nonpartisan issues. But until we have elected officials in office who are willing to step up to industry and step up to special interest groups and say, no, you don't get carte blanche anymore. We're going to fight to fix the environment, even if that means that there have to be some sacrifices. So right now, the industry in the Everglades agricultural area has a ton of impact when it comes to how water is moved around in our state. The agricultural industry south of the lake is wonderful at lobbying. They've got strong bipartisan support of the work that they do. And as a result, they get perfect irrigation. So I know there's a lot of information on this slide. You can ignore most of it. I just want you to look at the red ovals, the green oval, and the red box. This is a map showing how water is moving during the dry season. And what you can see is that on this day, there is over 800 million gallons of Lake Okeechobee's water flowing into the Everglades agricultural area for irrigation purposes. Most of these numbers at the bottom of the map are zeros. Water's not getting into the Everglades. It's going to irrigate fields in the Everglades agricultural area. Thankfully, there isn't any water coming into our estuary, which is what we always want. Remember, we don't need any Lake Okeechobee water in the St. Lucie. Also, thankfully, there is some water going into the Caloosahatchee. Please recall that the Caloosahatchee is different than the St. Lucie. It needs at least a little bit of water from the lake or it will get too salty. Let's flip gears to the wet season. 1.2 billion gallons of water on this day dumped from the lake into the St. Lucie, much more than that into the Caloosahatchee, and 0 went from the lake into the Everglades agricultural area. Those fields are bone dry when the rest of us are flooding, and they're perfectly irrigated when the rest of us are under drought advisories. Until we can gain some control over the way that water is managed, we're not going to see any changes. So even though the Everglades agricultural area is a lot cleaner in terms of pollution than it used to be, they are still holding the keys to how water is moved in Florida. But we can fix that. And there has been a lot of movement towards fixing that, both scientifically and politically. First, I want to introduce the Comprehensive Everglades Restoration Plan. This is the largest environmental restoration project on Earth. There are 68 main components to the Comprehensive Everglades Restoration Plan, and those components are designed to clean up the Everglades and improve water quality and environmental health. This was signed into law in the year 2000, 23 years ago. Only one of those 68 projects has been completed. The one that's been completed was a low-hanging fruit. It wasn't a real substantial project. But we are moving in a better direction. One of the most important projects in the Comprehensive Restoration Plan involves building a big filter wetland in the Everglades agricultural area. A wetland where the Everglades used to be. That wetland will filter water coming out of the lake so it can then be cleaned and free of nitrogen and phosphorus, allowing it to flow back into the Everglades where it was needed. We're moving in a good direction, guys. They have broken ground on that project. We are getting some state and federal funding. It's moving slowly, and it's not as big as the original plans called for. And there's a lot of, there's a big political backstory there, but at least it's a step in the right direction. The other big thing that we've watched develop over the last couple years is LOSOM, the Lake Okeechobee Systems Operating Manual. This is a really complicated graphic. Ignore it, don't worry about it. What this is a playbook that the U.S. Army Corps of Engineers uses to decide how much water to let into the lake, how much water to let out of the lake, and where to let it out. The existing playbook is called LORS. LORS wasn't working very well. LORS was written largely to guard against flooding in the Everglades agricultural area. Now, bear in mind, flooding in a farm field is not flooding like you and I would think of flooding. To me, flooding is where I have wet feet if I don't have boots on. But the Army Corps of Engineers, as mandated by Congress, has to protect agricultural interests from any form of flooding, and that means wet dirt. So if the water table in the Everglades agricultural area rises too high and the roots of the sugarcane get wet, that can cause crop damage, and the Army Corps is tasked with protecting those fields to the same level that they would protect a school or a hospital or a town. That's not going to change until we get political support in Washington, D.C. to make that change. In the meantime, the Army Corps is doing what they're mandated to do by Congress. But thankfully, LOSOM will start to look at all shareholders more equitably. Rather than only focusing on protecting industry south of the lake and special interest groups, LOSOM listened to all of our voices. And this is a 4-year planning process. Some of you may have even gone to local meetings here in Stewart and gotten on mic and spoken out about how important it is for the Army Corps to manage water better in Florida. And right now, we're in the final stages of this. Hopefully by sometime this year, we will see this enacted and implemented, and ideally, LOSOM will keep water out of the St. Lucie River. It will give the Caloosahatchee just the right amount, not too much, not too little, and it'll get more back into the Everglades. This is an example of our voices as community members, as anglers and boaters and hunters and fishermen and business owners that are impacted. It's an example of our voices finally being heard. This really has been a positive process. There have been some hurdles, and we've actually seen the environment come out pretty good during the LOSOM planning process. And that brings me to my final point, guys. You're the only solution to these issues. You need to take your knowledge and share it broadly. You also need to use your vote. I don't care who you vote for. Take your favorite candidate and call them. Send them an email and tell them that they need to do better. Doesn't matter what party they're in, doesn't matter what level of government we're talking about. Take your candidate that you support, that you endorse, that you vote for, and tell them they can be more environmental. This will work, and it is working. Real quick, this year there was a piece of legislation that was slipped in at the last second as a budget-conforming bill, tagged onto another piece of legislation. It was written as an environmental bill, but it was anti-environment, and thankfully some environmental groups found out about it. On the Florida Oceanographic Society website, we provided people with a link where they could send an email to their representative demanding that this bill not make it through legislation. There was also a petition that was circulated in Florida, and it received 47,000 signatures. In the end, this harmful legislation that would have set us back decades under the guise of being pro-environment was vetoed. And the only reason it was vetoed is because the people of Florida spoke up. Just today, our governor, Ron DeSantis, had a press conference, and he announced that because of you pushing him, he's going to do what he can to continue furthering to support Everglades restoration. Let me look at some exact numbers. I don't want to get these wrong. I wrote these down because I'm not a number guy. But he pledged to secure $3.5 billion of support for Florida's waters over the next 4 years, with a focus on the health of the Everglades. More importantly for me, he's going to secure $1 million a year for the Indian River Lagoon. This is an unprecedented announcement. Nobody's talked about the Indian River Lagoon at upper levels. We hear about the Everglades a lot. Today is the first time I've heard somebody in Tallahassee speak that clearly about the Indian River Lagoon. So this is a great example. No matter who you vote for, you could still send our leaders an email and say, hey, keep doing better, or if you're not doing enough, start doing better. And with that, I just want to thank you for being here tonight, and I want to encourage you all to remember that your little voices led to these changes. Thank you very much, guys. So folks, we'll bring the house lights up a little bit. If any of you want to leave, that's fine, but we've got at least 10 minutes for a discussion. I'd be happy to answer any questions, starting with our in-person audience. Folks on Zoom, if I had to guess, you've probably been typing questions in all evening. I'll do my best to check my iPad at some point and see if I can answer some of those. But again, because I'm not moderating, I'm speaking tonight, it might be a little challenging. Let's start with our audience here in person. Yes, in the back. Who was the author of Senate Bill 2508 that was just defeated? I always have to remind myself of this. It is Senator Albritton. Pronunciation always slips me. So Senator Albritton wrote the legislation to have a lot of environmental sounding language in it, but if you read it, it actually took away some of the power of LOSOM. It tied up funding that was to be used to build that filter wetland. And then it also, kind of sneaky, it locked up funding to fix the Everglades contingent upon the passing of the bill. It was a sneaky, sneaky thing, and I will tell you that people drove to Tallahassee to testify against this bill, and they were mocked and ridiculed on camera in front of the Senate, but their passion prevailed, and we ended up eventually succeeding. Well, so it's a comment from the audience that we really don't need to fertilize our yards. There's enough nutrients that are coming in naturally. And I'm repeating these questions just so the folks on Zoom can hear. I kind of asked you to fertilize a little bit less, but I didn't overtly tell you to fertilize yet less. But the truth is, in Florida, you can get away without fertilizer because a lot of our tap water has nutrients in it, our rainwater has nutrients. And if you want a green yard, you can fertilize with iron. Iron will not cause algae blooms. It doesn't really cause your grass to grow quickly, but it'll keep it green. So you don't need to fertilize your St. Augustine grass. It's a myth, like the 3,000-mile oil change. Try it 1 year and see. If you keep your grass watered, you'll have a good lawn without destroying the environment. Thank you for that. Yes? Yeah, great question. Why don't we start importing sugar from outside of the United States? Well, in the couple minutes we have left, I'm going to barely touch the tip of the iceberg on this, but I'll try. Sugar is a subsidized crop. There are protections for the sugar growing industry that date back to the colonial period in the United States. In the colonial days, we wanted to buy sugar from U.S. colonies in the Caribbean, not foreign colonies. Language to protect the sugar industry remains intact in today's Farm Bill. Sugar doesn't grow in Florida very well. It's a tropical crop. It's easier to grow in the tropics. It's cheaper to grow in the tropics. It's better for the environment to grow in the tropics. And because of that, consumers outside of the United States buy sugar at a much lower price than in the United States. But because there is not a free market economy for sugar in the U.S., We are paying twice the global price on average for sugar. That doesn't affect me much at Publix when I buy a little bag of sugar, but imagine if you own a business that uses tons of sugar each year and you're paying twice what your competitors are paying in other countries. The reason that we aren't importing more sugar, and we do import a little, but there are import quotas and there are price controls and tariffs. It's a really complicated story. It's another hour-long lecture, but you asked about the reason. The reason is because the sugar industry, which in Florida is primarily driven by two major jumbo corporations, they have successfully lobbied politicians for a very long time to keep the status quo. Where it gets tricky is that in the Midwest, there's another sugar industry, the sugar beet industry, that's dominated by smaller family farms. Legislation right now that impacts sugar cane also impacts sugar beets. So what we're doing in Florida could impact smaller family farms in the Midwest. In a perfect world, we would see a separation of those two industries. We would see possibly changes to the way that sugar is imported in the US, and we would see prices coming down. We maybe would see that it's no longer lucrative to grow sugar in the Everglades agricultural area, and either that land could become conservation land, or at the very least, we could grow a crop that we can put on the dinner table. There are other crops being grown out there. You'll hear the sugar industry all the time tell you about their corn and their sweet peppers and their rice. Don't fall for that. I mean, it's really a sugar-dominated area. I would much rather see agriculture that's putting food on the table, not industrial agriculture that's producing a chemical, sugar, that's hurting the environment, polluting our air, and hurting our economy. All right, we have time for a couple more questions here. Yes, sir. So the question, summarizing it, was, isn't it better to keep feeding the manatees now to fend off acute starvation rather than just letting them die, even though we know ultimately the long-term solution is cleaning up the water and letting the grass regrow? My opinion on this may differ from a lot of yours, but I would say no. There's a term in ecology called carrying capacity, and animal populations fluctuate based on the capacity of their environment to sustain them. We have more manatees prior to the year before last than we've ever had in Florida, at least in modern times. And we, in some ways, have caused that to happen by putting these power plants in, allowing manatees to thrive in areas where they hadn't previously thrived over winter. So as sad as it is, in order to preserve the health of the environment and manatees in general, that carrying capacity is going to come down a little bit until the estuary gets healthy. If we continue feeding these animals, we're just going to keep the population getting bigger and bigger and bigger at a time where the environment physically cannot sustain the number of manatees that we're feeding. In a perfect world, maybe we could find a compromise where feeding is used very selectively under very controlled circumstances to get them through the worst part of the year. But if you just keep feeding them for months and months at a warm water discharge from a power plant, you're only going to continue that social learning, and they're never going to migrate. They're never going to go back to doing what manatees are supposed to do. And in the end, you could end up with some other population collapse related to disease or a change in the environment. But believe me, I understand that the idea of letting manatees starve versus feeding them is controversial, and I probably come in on an extreme side as an ecologist. What's being done is absolutely helping the manatees, but at the same time, it's not addressing the bigger issue of how do we fix the Indian River so the grasses will grow back and the manatees will have a natural food source. Yes, sir. The question was about the shorelines here in the Indian River and the St. Lucie being covered in a bright green algae. Without me seeing it directly, I can't tell you exactly what it is, but I will say that there are lots of bright green types of algae out there that aren't bad. A lot of them are still indicating that the water's polluted. So when you see that film of bright green at the high tide line, that's a sign that we have too much nitrogen and phosphorus in the water. But usually the stuff you're talking about is a little bit like hairy and fuzzy, filamentous. Typically, that stuff isn't toxic, but it's still a sign of pollution. I think we have time for maybe one or two more questions here. Yes?
Why can't we use some of the pollution, recycle it as fertilizer, like the seaweed that you showed us, or from the wastewater plants?
Really good question. Why don't we use some of the algae that's causing this problem as a fertilizer? A couple problems. Some of the worst types of algae are toxic. And believe it or not, they've started to find toxic levels of BMAA in crops that are irrigated with water where cyanobacteria is growing. Now, dry that out, grind it up, and put it on a field, you've really potentially vectored those toxins into a food crop. Even sargassum, they're trying to figure out ways to compost sargassum and use it as a fertilizer. It traps heavy metals. So ideally, that would be great if we could reuse those things, but there are obstacles. Using waste from sewage treatment plants is a big issue. You can take the solids from a wastewater treatment plant and create a fertilizer called biosolids, spread it on the land, and it acts as a fertilizer. The problem is, if you use that in Florida with our water table right below us, it goes right back into the water and it starts the problem all over again. There are places where biosolids can work. Florida's not a great candidate for that. Any other questions? Yes, in the back.
I know this might have a cost problem to it, but could the algae be used for fuel?
Great question. So the question following up with the previous question, what about using the algae as fuel? There are examples of algal organisms that are being grown in laboratories to make biodiesel. But as far as I know, it would be almost impossible to do that with wild algae. The species that are used for fuel are grown specifically because they produce a lot of oil inside of their body. They're also not toxic, and they're easy to harvest. If you go out into the wild, you can't just skim this stuff off the water and use it. The scale of Lake Okeechobee is so immense that you wouldn't be able to effectively vacuum this up or skim it up or slurp it up. I see where you're going with that. I think it'd be great if we could find some way of reusing these problem organisms. There are scientists out there right now working to figure out if there is anything that can be done with it. The problem is it's just so darn toxic, it's really hard to come up with something positive to do with it. Folks, if you'll hang out with me for one more second, I'm just going to see if there are any real easy questions to answer from our Zoom audience. I'm not sure how this is going to work, but I'm going to give it a try. We have to start somewhere. All right, let's see here. Bear with me just a second, guys. Let's see here. Great question. All that water that's being used in the Everglades agricultural area. Remember I said in that one graphic, that day 800 million gallons were going into the EAA? What prevents that water from going back into the lake? In the past, when there was too much water in the Everglades agricultural area, the state of Florida, not the farmers themselves, the state of Florida would back pump water from the canals north into the lake. And that's how those legacy nutrients got into the lake in the first place. Pumps were run to move water against the grain back into the lake, and those nutrients then became part of the lake's problem. Back pumping is illegal now, so that water, once it's in the Everglades agricultural area, has to continue going south. Currently, when it goes south, it ends up in a series of 6 stormwater treatment areas. These are filter wetlands that we already have, smaller than the one that they're building now, but they work really well. It's a proven technology. The problem is our current stormwater treatment areas are only being used to clean the water coming out of the farm fields, not to clean Lake Okeechobee's water for the purpose of getting it back into the Everglades. Great question, everybody. Let's see here. Let me just see if I can find one more. I'm starting to see that this is tricky. I'll figure this out better for next week when I'm moderating. So somebody asked, if we buy sugar from outside of the country, doesn't the pollution just move from here to another country? Other countries have far fewer environmental controls than the US. We need better controls for our pollution. I would agree with that. But here's the thing to remember. As a tropical crop, sugar grows with less intensive cultivation in the tropics than it does here in Florida. It doesn't need to be fertilized as heavily. It's a crop that can grow without as much human intervention when it's growing in its prime climate. When you grow it in Florida, further north, it takes more energy to grow it. It requires more fertilizer, it requires better irrigation, and in that case, it's probably better to grow it in the tropics, even though we are just doing the old not in my backyard thing and we're sending that pollution elsewhere. It can be grown more sustainably outside of Florida than it can be grown in Florida. It can also be grown cheaper outside of Florida. there's really no reason to keep growing it here other than sustaining the status quo for a couple of really, really large businesses. And with that, I think I'm going to wrap up both our Q&A session online and in person. Folks, thank you so much.